y'all should be seeing the board now. That's supposed to be shining up there, but they got some kind of glitch in it. So. Oh, but I don't think fixing it all. Here we go. All right, y'all. So chapter 3, we're skipping around. We're doing chapter 3, section B. So this will be 3B. All right, y'all hear me online? Okay. I've had to mute.
Yes, I can hear you.
Okay. All right, y'all. So 3B deals with putting numbers in perspective. So we're looking at very large numbers and very small numbers. Now, if it wasn't for a pandemic, I'd have brought everybody 2 balls, and we'd have played with like scaling the Earth and the Moon and stuff like that. But since we got the pandemic going on, we can't really touch stuff with each other, right? So I'm gonna try to find y'all a little project, and I'll bring it next time for Thursday, dealing with some of that scaling, okay? Just like a roadmap, right? You can't put 2,000 miles worth of road on a little piece of paper for a map, can you? So if you notice on the map, it'll have a little scale down there. 1 inch equals 100 miles or something like that. All right, so we're going to be dealing with writing large and small numbers. And I'm going to look specifically at what we call scientific notation. All right, so scientific notation is just a format in which a number is expressed as a number between 1 and 10 multiplied by power of 10. So what they mean by powers of 10, I'll show you a scale over here about powers of 10. So this gives you an idea about these powers, okay? So 10 to the 0, actually any number to the 0 power, oh, go up. 1, there you go. That's tricky. I get them to call God on that all the time. But yeah, put it on the calculator, put your 0 exponent. No matter what that number is, it's going to give you a 1 for that, okay? And then remember, exponents just tell me how many times 10 got multiplied by itself. So 10 to the first is still going to be 10. 10 squared would be like 10 times 10, which gives me what, 100. Multiply Multiply by another 10, I get 1,000. And then times another 10, we get 10,000. What I want y'all to notice, the exponent really telling me how many zeros are following in one, right? 10 had 1 0. 10 squared was 100, which had 2 zeros. So the exponent is really telling me how many zeros are going to follow the 1. Okay. But the exponent ain't always positive. So if 10 to the 0 is a 1, 10 to the negative first, this would be like a 1/10, which could be a 0.1. Right, 0.1, basically 10 cents is 1/10 of a dollar, right? 10 to the negative second would be like 1 over 100. So that'd be like 0.01. Then finally 10 to the third, 1 over 1,000, which is a 0.001. So when you're dealing with negative exponents, there's one less zero before the 1 than the exponent, okay? Are y'all familiar with your place values? Like on the number line? Yeah. Your ones in the middle, your tens, hundreds, thousands, positive way. Negative way, you got your tens, hundreds, thousands, what's next? 10,000 and so on, okay? Just remember when you go into negative, it's got like a TH at the end of the thousand, it'd be thousand, or tenths with a TH at the end of them, okay? All right, so here we go. To convert to scientific notation. All right, so remember, I could be dealing with very, very large numbers or very, very small numbers like 0.000 type stuff, okay? So the first thing you want to do in scientific notation is move the decimal So we're going to move the decimal point to come after the first non-zero number. Or I might even say non-zero digit. So y'all, if I got a really big number, my decimal will be after the last number technically. So remember, if there's not a decimal shown, it's automatically after the very last digit. Okay? So that means I'll move that decimal all the way left behind the first non-zero number. Okay. All right, step 2. So we got to look at what's going to happen to the power of 10 in this case. So for the exponent or power of 10, use the number of places moved by the decimal point. So number of places moved by the decimal point. So I'm gonna move my decimal behind the first non-zero number. Ever how many places I moved is going to be the exponent on that 10, okay? Now, there's two things that can happen on that. The power is positive if the decimal moves left. That makes sense. If I got really big numbers, they're going to have positive exponents. So they're going to be in these tens, hundreds, and thousands. Okay. The power is going to be negative if we move the decimal point to the right. Okay. So in the final form, you'll have your number, say like 1.23 times 10 to some exponent, okay? So let me write this as an actual problem. So let me convert a number into scientific notation. All right, so my first one, I'm going to do 328,000. So a pretty big number. So, like I said, there's no decimal shown. So where is it at? So y'all remember, if there is not a decimal shown, that decimal's got to come after that last number. Okay. I'm going to say they won't be writing point in all the other zeros after that, unless you're looking at accuracy, like in chemistry. They get really accurate in there, you know, so they might go past the decimal point. But all right. So the first non-zero number going left to right is at 3. Which means I got to move my decimal behind that 3. Now I'm starting on the left side, so remember, if I move left, when I'm done, my exponent will be positive, okay? So starting over here, I'm going to go 1 unit, 2 unit, 3 unit, 4 unit. So I went 5 digits to go left and get behind that 3, right? So that this answer will now be 3.28. Now, do I need all these zeros?
Okay.
No, because that 3.28 covers everything I need, okay? Now we write times 10. So all of them will have times 10, and then what exponent am I putting?
5.
That's 5. And notice, well, we didn't go to 10 to the 5th. Remember, 10 to the 5th would be 100,000 over here. Well, 3.28 times 100,000 will give me 328,000, right? So they use this stuff, especially in physics and stuff, when you're dealing with like the mass of the earth or the diameter of the earth and stuff. Those are pretty big numbers, okay? All right, we're gonna go the other way. 0.00000314. So that's a fairly small number, but y'all in seems like when we did chemistry back in the day, electrons, you can't see electrons, they're parts of atoms, right? Their mass has like 23 zeros in front of the number. Okay? That's quite a bit of zeros. So they don't want to write 0.0000043 times this big mass of electrons. So they use that scientific notation. Okay? All right, so this one, I'm going to move the what's it called, the decimal point to the right. And I'm going to behind what number?
The third.
3. Remember, that's the first non-zero number going left to right, right? So I want that decimal point fit right in there.
Why are you doing behind the 3?
Because remember, I need it behind the first non-zero number.
Oh, it's right up there.
Because when you're done, you want a number, the first number has to be between a 1 and a 9, basically. Because if it was a 10, I'd have to move decimal again. So you want it behind the 1, 2, 3, 4, all the way up to 9. So that decimal, the number you're moving the decimal to, it can't be over 10. Cannot be over 10, and it cannot be less than. Okay. So, watch this. We're going to go 1, 2, 3, 4, 5, 6 units. So I'm going to move behind the 3. That's going to give me 3.14, which is definitely between 1 and 10, right? So this will be 3.14 times 10 to the
Minus 6.
what did you say?
Minus 6.
Say it one more time.
Minus 6.
-6. Let me say this. 1, 2, 3. Perfect. So I'll move right. So decimal numbers that are like 0.00s are going to have those negative exponents. Positive values will come from numbers that are bigger than 10. Okay. So let me ask you, what would y'all do with this? 16.3 times 10 to the, let's see, I want that to be second. It looks like it's in scientific notation, but is it in scientific notation? No. Because
It's 16 is
It's
bigger than
6.
9.
Because the 16 is bigger than the 9, right? So although it looks there, it's not quite what I need. So to make this one in the scientific notation, this decimal has to be behind the 1, right? So that's going to give me 1.63. Here's the question though. Is the exponent going up or down?
Down.
So I'm going to say, because remember, I'm moving to the left,
Third.
which means every time I move units to the left, I'm adding to those powers, right? Every time I move to the right, I'm basically getting more negative on them, okay?
You said I didn't hear you with the right.
Say again?
You said when you move to the right, it
Well,
does what?
So when I move my decimal, this will actually move from behind the 6 to the behind the 1.
Uh-huh.
So since I move left on that, I add 1 each time I move left to my exponent.
Okay.
If I move right on those, and I put my decimal to the right, I
Uh-huh.
would be subtracting 1 every time.
Okay.
Okay. So that gave me an exponent of a 3 then, right? Now, if you punch 16.3 times 10 to the second, and then you punch that 1.63 times 10 to the third, they're going to be the same value. They're just written in different methods, okay? But the correct one for scientific notation, we had to move that decimal. Okay? So you cannot have a number in front of that decimal bigger than a 9. All right, let's see. 0.23 times 10. So let's do one with negatives. 0.23 times 10 to the negative second. Is that one in scientific notation?
No,
Mm-mm.
Because of what?
the 0.23 is bigger than 9.
Well, that
The
0,
zero.
actually, the 0 is less than 1.
Nine.
And he also said that my decimal had to be behind the first non-zero number, right? So I'm going to have to move this to the
To
right.
the right. 2.3.
So I'm going to get a 2.3 times 10 to the what? -3. Because I moved right this time, so every time I move right, I'm subtracting 1 off that exponent. It's getting more negative each move I go, okay? So you said -3? Okay. So there's going to be times when you add these together, and you're going to get numbers like 14.7 times 10 and whatever. Remember, although that's what you got on the answer, that's not scientific notation. It cannot be a 14, it's got to be a 1.4, and so on, okay? Oh, let me go the other way. Let's convert from scientific notation. Y'all notice we ain't got to rush this. That's the only thing doing this week. 3 beats stuff, okay? So I'm gonna really still focus on that power of 10 on these, okay? So the power of 10 is going to tell me how many times to move that decimal. Right? But we also got a sign on that power of 10, right? It can either be positive or negative. So if that power of 10 is positive, so we have a positive power of 10, we move the decimal right. Right, so if I had like times 10 to the third, I'm going to take that decimal, move it right 3 units. If it's negative third, I'm going to move it left 3 units, okay? So with negative power of 10, we move the decimal left. Now, Then we gotta know on this. So let me ask, I'm gonna put an example up here and see what we would do to this. What if I had something like 2.5 times 10, we'll use 10 to the third. But that 3 is telling me to take this decimal and move it right 3 units. But y'all, I've
Ain't
only
no
got one number to move it to. So what do I need to do?
subtract.
Add 0.
Add zeros.
Oh,
to it,
wow, okay.
right? So I would have to add a 0, make that 2, and then another 0 to get my third move. So that would basically give me what, 2,500. Now remember, if the decimal follows your last number, you don't have to write it on your answers, okay? So that answers my last case, I guess. If moving the decimal creates open spaces, fill them with zeros. Okay, so that's probably one of the biggest tricks. If you remember, them zeros can come in there, okay? Now, usually in your sciences, y'all gonna learn about stuff called significant figures and all that. So that'll give you more practice on scientific notation. So I'm gonna convert out of scientific notation. Convert from scientific notation. All right, y'all, so my first one, I got 4.01 times 10 to the second. All right, any guesses on that? I got 4.01 times 10 to the second.
401.
401. Because all you want to do, so since we're just converting the number out of scientific notation, I'm looking at that 2 sitting there, right? That's telling me to take this decimal that's at the positive 2 and move it right twice, right?
Mhm.
So basically, you would have a 401 with a decimal, but do I have to write that decimal? No, I'm just going to make that a 401. I'll tell you, the only way I would write a decimal after that, like a 0.0 or something, is if they told me to be accurate within the nearest tens or hundreds or something. If you round into those kind of units, they might want them zeros and stuff, but we end up big in here. Okay. 3.6 times 10 to the 6.
That freeze.
Now remember, 10 to the 6 is a 1 with like 6 digits behind that, so that's like a million, right?
He froze up.
I
That's
know.
pretty good, right? Oh, my
The
frozen
screen's
line?
frozen.
Your screen froze.
Hey, let me stop the share and go back to it. Hang on just a second.
Okay.
Okay,
Let me see. Can y'all see me now moving?
yes.
Yes.
Okay. That's our internet over here. It's like a little lag this time. How's your little laptop doing on this internet? It does, you know. So they're probably a pretty big number then, right? But notice this is going to hit this kind of. There's not 6 numbers after that decimal. So this is where I'm going to add a lot of zeros, right?
Mm-hmm.
So from the front of the 6 to behind it is 1 move. I got 6 to do, so here comes 2, 3, 4, 5, and 6. So let's see if I got it. 1, 2, 3, 4, 5, 6.
6.
So that would technically be what, a comma there,
Yeah.
and over there. So we said 10 to the 6 was a million. So 3.6 times a million is 3,600,000, right? So yeah. U.S. economy, or the what do you call it, our deficit is like 20-something trillion. So that would be from a million to a billion would be from 10 to the 6, 10 to the 9, right? From a billion to a trillion, you add 3 more zeros. So times 10 to the 12 is the U.S. debt, okay? Oh, hell, they got to add another 2 trillion to it, right? 1.9 trillion package going to. Right? It's gotta end sometime. All right, let me see what I got next, y'all. I might as well go the other way. 0.0000037. Oh no, I'm going the wrong way. Y'all hang on a second. I got the wrong problem. How about 3.7 times 10 to the negative? That's what I need. We're gonna change it 3.7 times 10 to the negative fifth.
Are you gonna move left?
Huh?
Are you gonna move left?
I'm gonna move left. There you go. But I can only go one number, so I'm gonna add a lot of
Zeros.
zeros. You know, that looks like I need about 1, 2, 3. Let's see it. 1, 2, 3, 4. I need 1 more zero. So 5. And I'll tell you a trick. If your number's after the decimal after that first non-zero number, you're basically going to add 1 less zero than it's in that exponent. So since my exponent was a 5, I only added 4 zeros to get my units moved. Okay. If that was a 7, I would move that thing. I've got 6 zeros. Okay. All right. Well, let's see what we get. Point. 4 zeros and then a 3, 7. Okay.
You don't put 5 zeros.
What else?
You don't put 5 zeros.
No, because what's happening from going behind the
Okay,
number,
yeah.
that's not. So that's why I subtract 1 from the 5, but then 1, 2, 3, 4 more moves. Okay. Now, if you're going the right way, you'll have that many moves total. Okay. It is, man. This should bring that memory totally. Right. All right, so I guess we're ready to add, subtract, multiply, and divide. Yeah. All right, y'all. Operations with scientific notation. Well, we might not finish these all today, but we're going to get a good start on, all right? And I'll tell y'all, sometimes in math, multiplying and dividing are a lot easier than adding and subtracting. Especially fractions, right? Fractions, you can multiply straight across, get your answer. Adding fractions, you gotta find common denominators. Scientific notation, I can multiply any number times any other number pretty quick, but when I add these, I need to try to get the powers to match up. Okay? So let me refresh y'all on some exponent rules. And this would mainly be for your multiplying and your dividing. Okay? So multiplying. I've got an exponent rule that says if I got matching bases, which for y'all the x's would be the 10s, like 10 to the 5th, and I'm going to multiply by something like say 10 to the 3rd. Okay? If you got the same bases, when you multiply variables or you multiply the same base, you take the exponents and add them together. Okay? So I'll show you some examples with powers. 10 to the 3rd times 10 to the 2nd. Notice my 10s are like the bases. Those are the x's on this. So since they match up, I'm going to bring the 10 over. What exponent am I going to give it? 5, because 3 plus 2 is 5. So remember, add them exponents when you multiply the same base. Y'all ever multiply by x's and x's? In high school, you did x times x is
Mm-hmm.
x squared, right? You remember that? I'll bring back memories. Well, we don't do that right here for you, but okay. What about this? 10 times 10 to the 7. So she said 8. She said 10 to the 8.
And you put a 1 up there.
Because if there's not an exponent, it is definitely a 1. Right? So no exponent on the 10. It's got to be a 1. I get them in algebra, they put zeros there. But y'all, 10 to the 0 ain't a 10. 10 to the 0 is a what? 10 to the 0 is 1. What if my exponents are negative? I got a 10 to the negative 4 times a 10 to the 5th. What's my final answer? 10 to the first. To the 5 plus the negative 4. When you got unlike signs, you basically are subtracting and giving the sign of that larger number. And notice if I got a 10 to the first, I made that a 10. Math lab, I think it freaks out if you put exponents of 1 because anything to the first power is itself. And it don't like fractions with 1s on the bottom either because anything divided by 1 is itself. So, all right, so how much more I can do to those other than both of them negative. 10 to the negative 2nd times 10 to the negative 5th. Would it?
And after you the teacher.
Okay, well, I'm at 2 negatives, right? So my bank, if I take out negative money, is they gonna make that positive? No. So here's the rule for if you're adding like signs, add the numbers and keep that sign.
You do
Negative
what now?
7.
So I say that if you add like signs like that -2 and that -5, add those numbers and keep that sign. Or my bank is doing everything wrong. Because I took out $5 one day, I took out 10 the next day, they didn't add 15 to that. They took out $15, right? But now if I was multiplying and dividing, two negatives would definitely make a positive, okay? So y'all, what was this answer? 10 to the
-7.
-7. Okay. So another exponent rule that will help us is for division. That would be something like x to the a over x to the b. Now remember, these x's for us are probably going to be 10s eventually. This will equal x. What do y'all think I'm going to do with these exponents that I'm dividing? I'm going to subtract them. And you always take the top exponent minus the bottom exponent. Okay? That's all you're doing is subtracting to be done. So examples of that, 10 to the 8 over 10 to the 3rd. But y'all, that makes sense. Even if you wrote them out 10 times 10 times 10, 8 times, and then on the bottom, 10 times 10, 3 times, you can cross out 3 whole sets of those 10s, right? And then whatever's left on top would be my final answer. Would it be 10 to the? Sounds good, right? 8 minus 3 is 5.
So you're minusing that 8 and 3.
Right. Because those 10s matched up, which are my bases. So now all I do is come in and just subtract those exponents. And just keep my bases the same on those, okay? Oh, let me throw a negative on here. 10 to the 8 divided by 10 to the -3rd.
So it'd be 10.
10 to the 11th.
Yeah,
Say that
No.
again.
10 to 11, she said.
Someone said 11. Someone said 11. I like that answer, right? I'm going to put 11 because remember the exponent is what? 8 minus a -3. So when you subtract a negative, you make it a positive.
Positive.
So good job on there. All right, so I'm going to start playing with a little bit of multiplying and dividing, and then probably next class we'll pick up on the add and stuff. Okay. So let me find one I want. So these I'll just put multiply or divide. Now, usually they'll keep each number in its own set of parentheses, okay? So let me show you what I mean. I'm going to do 6 times 10 to the 2nd times 4 times 10 to the 5th. So the trick on these is to multiply the numbers first and then multiply those powers again. So we will have something times 10 to some exponent when we're done, okay? So first, we want to multiply the numbers. So I got a 6 times 4, 24. So that's going to be 24 times 10 to the something. So now these bases match 10 squared times 10 to the 5th. So what are we doing to those exponents?
Adding.
Adding. All right, so 2 plus 5
7.
is 7. So I got 24 times 10 to the 7. Is that my final answer?
No.
No, because it violates scientific notation, right? At the moment, my decimal's behind the 4. But I need it behind the 2, Donna. Because 24 is a lot bigger than 9. Okay? So although this is the right answer, it's not in the right form. So our decimal has to go from that behind that 24 to behind that 2. So do y'all remember? If I make this a 2.4 times 10, am I adding or subtracting from that exponent?
Adding.
Adding.
I'm adding that. So I moved one place, so that will now make that a 8. Okay. So y'all watch out when you multiply these numbers. If you get something bigger than 9, you got to move in decimal, okay? We're not too bad with it.
So that's the form we give for the answer. You want to
It's
break
gotta
that
be-
down further?
Yeah, it's got to be with that decimal behind the first non-zero number on those, okay?
So what I'm saying is we don't give the answer, it's 24 million or whatever.
Oh, no, Now, there will be some problems in there where they want you to convert these into standard notation, I call it. And then it might want you to know what these units mean. So if that's an 8, that's pretty big. So we know 6 zeros was what, 1 million? So that'd be 10 million, and another one would be what, 100 million? So that's in the 100 million range, okay? Pretty big number. All right, 7 times 10 to the negative 2 times 1 times 10
Yeah, it's already set up.
to the negative
I need
30.
that.
She needs that. That's why
Yeah,
I'm-
thank you.
Okay. I'll get you what I want.
Oh, am I not looking at my pros again? No, let's see that. All right, so first I'm going to multiply the numbers. So I'm going to multiply 7 times 1 and get a 7 times 10 to the 1. I got a negative 2 added to a negative 3.
-5.
5.
So negative 5. Good job. And that one technically is in scientific notation, right? I know that my decimal automatically is behind that 7. So you just got to sort of look at them when you're done and say, whoa, is that first number what I need? The one I had with the 24 wasn't in the right form, okay? That one I had a 7, so we're good to go and move on. $6.5 times 10 to the third divided by, oh, what I want on that? Oh, divided by itself. What's going to happen to that? And I want you to see the exponents too, okay, on this? So at first, We'll do 6.5 divided by 6.5. Which is definitely give me a 1, right?
Mm-hmm.
Over here, I got 10 to the third divided by 10 to the third.
0.
We're gonna figure out what to subtract exponents. But 3 minus 3 is
0.
0.
so is 1 times 10 to the 0 the same as 1? What was 10 to the 0 you said a while ago?
It's 1.
1. And 1 times 1 is definitely
1.
So I wanted y'all to see still, no matter whether it's numbers, scientific notation, decimals, anything divided by itself will still be 1, okay? All right, y'all, 4.2 times 10 to the negative second divided by 8.4 times 10 to the negative fifth. So if you want to hit that on the calculator, do the 4.2 divided by 8.4. So y'all can tell that is
24.
well,
0.5.
there you go. So divide this one by that. But you're on the right track. Instead of a 2, it'd be a 1/2, but 1/2, how they put it on that?
0.5.
0.5. Okay. So when you divide this, you get a 0.5. Now, had that 8.4 been on the top over 4.2, then that would have definitely turned into a 2 on that. Okay. All right, 10 to the what? So now y'all got a -2 minus a -5, which is like a -2 plus 5. So -2 minus 5 give me
7. Oh, 3.
8.5 times, what was that, 10 to the third? Am I done?
Got over decimal point.
I gotta do this one. It's gotta be behind the 5. Good job. Oh, but I forget what to do with the exponent if I move to the right. Am I adding or subtracting? Subtracting. Because remember, where was I? Well, remember the 24, I moved to the left, I added. If I move right, I got to subtract it. So if I move right, this becomes 5 times 10 to the second. There you go. Okay. They're not too bad. It's just keeping up with all these rules. Okay? That's why I'm just going to multiply and divide today, and then next class we can worry about the adding. All right, so I was going to do. So I'm just going to sort of finish using some of these examples that I did with some of the problems you might see on the homework. Okay. So these would be 3B homework examples.
You said 3B or 3G?
3 Bravo, B, Bravo, Beta. Military lingo, right? So just tell me if these make sense or they're like way out there. So, does this make sense? I read a book. With 10 to the 5th words in it. So the question would be, are there books out there with 10 to the 5th words? So what was 10 to the 5th? 10,000. So I'm just gonna go to the shortcut here. 10 to the 5th would be a 1 with what? 1, 2, 3, 4, 5 zeros. So not 10,000, but 100,000. So is that possible?
Yeah, it's possible.
It's possible. Big book, but it's possible. So we would say, yes, possible. Learn how many's in the Bible, y'all know. That'd be a good project for y'all, right? What about this? I live in an apartment building. That is two times 10 to the second feet tall. So 10 to the second. That's basically 100 times 2 would be 200. Is it possible to have a 200-foot tall apartment building? Yes. Definitely, right? That'd probably be what's the average? About 10 a floor or something? So 20 stories maybe? Oh, where'd it go? Okay.
Oh, heart.
So this one wanted me to choose the best answer, okay? 86,400. They got that by 1 beat per second. Next, 1440. They got that 1 beat per minute. $86.40. They got that from 1 beat every 10 seconds. And then y'all finally, 432,000. They got that by doing 5 beats a second. So what would y'all pick for the closest one to your heartbeat? Well, hopefully it ain't 1 beat per minute, right? Remember, that'd be your heart rate. 1 beat a minute, that's not very fast. You're almost dead, probably, right? So there's a beat every 10 seconds. So beat, and then count to 10. And then beat again. Well, y'all, if you didn't pull this quicker than every 10 seconds, man. Hell, is it 5 beats per second? I doubt that would happen, right? That means your pulse rate would be 300 in an hour. Ain't going, 300 pulse rate, you ain't got that. Right?
We were
Well, I
talking about 90 per minute.
Yeah, that's if you're going, but they went with this one right here, going 1 beat a second.
I'm confused. What is the 86,000? What is
They
that?
just took, if you did 1 heartbeat per second, it would come out to this,
Per day or something?
per day.
Oh, okay, that's what.
And then this would
Okay.
be, at 1 beat per minute, you'd have 1440 per day. 8640 if it did 1 beat every 10 seconds, and then 432,000 if it did 5 seconds.
So this is for one whole day?
Yes.
Okay.
Now, some of y'all more athletic, might have better heartbeat, right? And that might increase, but they're just doing it on the average, I think for 1 second every boom, 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 your heartbeat, okay? So that's just stuff, but there's no way you're gonna beat 1 beat per minute, right? That means your heart's gonna beat, and then a minute later, it beats it again. Ain't happening. And I thought this was really outrageous, 1 per 10 seconds even. And then I thought 5 beats per second was a little too fast, right? I mean, that means your heart rate 5 beats per second, 60 seconds in a minute, that'd be 300 beats per minute. That's quite a bit. They hike up on coffee or something, maybe, I don't know. Right? Starbucks. All right, so I'm probably going to hold it off right there. So next class, what I'll do is I'll do the admin and practice. And then I'll play more with the magnitude so y'all realize the millions and the billions and the thousands and all that. Okay. So anyone got questions on this today? The main thing, just remember, converting into and out of the scientific notation. And that our final answer has to be written in scientific notation. Okay.
So should I wait to do that homework till the end of the week?
Well, I'm pretty sure you can knock out most of it now. The only thing, there might be a few where I added it or something, but you'll be able to knock out most of them, and then once I finish the adding, bam, knock them out and be done. But it starts out doing the stuff in the book. So let me say, converting, writing in scientific notation. So problem 5 is where it starts doing all the operations. So you would at least knock out the first half of this. Okay. And really, problem 5 is the only one where you got to go through and do all the operations. So you'd be able to knock out 6. They just want you to rewrite using scientific notation. The heartbeat one I did is in there. And then maybe 8, 9, and 10 you might wait on. So this asking like there are approximately 2.9 million deaths per year in country A. Express that as deaths per minute. So that'd almost be like I was doing the other thing with unit conversions. They're going from deaths per year. I had to turn the years into minutes, remember, by how many hours or days and all that. So that you got to do a lot of unit conversion on. So some of those I'm gonna knock out definitely next class. Yeah. So if you wanted to, you can get halfway through it at least. And then support just does a little bit of stuff like that. No question.
And are you gonna delete my, that thing that I've seen?
Yeah, I'll email me and I will definitely. Just email me and say, hey, knock out my number, whatever that was. Y'all probably gonna do report today, but next class, I'm probably gonna bring some kind of project for y'all. Sort of dealing with scientific notation type stuff. So if we need support that day, we'll definitely do it. Okay?
All right, have a good day. Thanks.
So y'all are all officially certified. I certified my roster yesterday, so that means the financial aid is on its way.
Okay.
That's what I said.
So we got certified for the no shows and all that, but I'm trying to clear all that out, so. Any of y'all get financial aid? And that should be like another week or two, right? It ain't. I tell you what, when I went to school, we got all that before we started school. And I went and bought my books and all that. And hey, I'm having fun, you know, but now they make y'all wait because we got too many people getting money and not really going to the school and stuff. So I gotta wait now. So next week, ooh, I'm gonna be. Okay, well, I'm gonna be making videos. Next week, what I'm gonna be starting to do is review for that first test. And it'll be due the Sunday after, not this coming up Sunday, but the next. So I will be doing my review like we're doing online now, so I'll send out the videos after.
I can just go back and watch the video and you know. Okay.
Yeah. All right, y'all, any questions on that?
Thank you.
No, sir. Thank you.
Thank
Okay.
you.
No,
Hopefully,
thanks.
Thursday, and then I'll get y'all ready for test one next week.
Okay.
All right, thank you.
Y'all have a good day.
You too.
You too.